Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I do data engineering and machine learning and other stuff at Databricks. And I'm joined by my wonderful co-host,
Ben Wilson. I investigate server column length issues at Databricks.
Today we are speaking with Barzan. He studied computer science at both UCLA and MIT, and then moved to the University of Michigan as a professor of computer science. He still teaches to this day, but recently founded a startup called Kibo, which is a fully automated cloud optimizer, and they're most famous for their Snowflake integrations. So Barzan, as Databricks employees, myself and Ben, we understand how powerful it is to automate back-end infrastructure, cluster provisioning, that type of thing. But I'm curious, as an academic, how did you enter this world? Were you using Snowflake and had pain points? Or what was the origin story?
That's a great question. So I think it's probably easier to just start from like the word Kibo. So it actually, our first idea is we're all about how we're going to speed up queries, right? So Kibo in Japanese means hope. So the idea was like, when you've tried everything else and all other hope is lost, like what else can you do? So it actually is an interesting intersection with the Databricks founders. We are actually with some of Databricks' founders, we're working on approximate query engine. The idea was because of Moore's law. So for those of you who are not familiar, Moore's law is predicting how fast hardware's price is dropping or hardware speed is improving. And then we were seeing that data volumes were growing at a faster rate than Moore's law, right? So it was pretty scary because, like, if you're a computer scientist or you know math, you know that when you have two exponential curves, once you fall behind, you're never going to catch up. So if the rate of data growth has already surpassed Moore's law, it means if you're happy with your performance, database performance, you're going to be sad next year. And if you're sad this year, next year, you're going to be depressed. So the idea was like, okay, you know what is it that we're going to do to close that gap? So there's a lot that's been done in the computer science community and in the industry, database industry, like whether it's indexing, data compression, parallelism, all of that stuff. And that's all great. And you have to do all those things. But the idea is that all those optimizations are actually linear speed up. So if you compress your data by 10x, you're only getting 10x speed up. None of these linear speed ups is going to basically help you eventually catch up or get ahead of that exponential curve. So that's where we start looking into statistical solutions to this problem. And then very quickly, we realized actually the problem is not just about Moore's law or speed. The likes of Databricks or Snowflake and other players in the space have done an amazing job of lowering the adoption barrier to sort of analyzing your data and getting insights. But what's happened is that because it's so much easier to get up and running and start analyzing data. Now there's a lot more users and applications that tapping into data, and they're tapping into a lot more data, and they're basically combining a lot more data sources. So now the cost of this infrastructure is going through the roof. And it just wasn't humanly possible for anyone, or even to this day, like it's not possible for you to look at, squint your eyes and stare at 1 million queries a day and say, you know what, I think here's how I'm going to reduce the overall cost, right? So that's where the story originated. We saw a real problem, and we're academics, and we thought about how we're going to create a solution. And I was always an outlier, even in academia, to be honest with you, because a lot of academics are just excited about coming up with theoretical solutions that are complicated and they can publish it. But for me, it was less satisfying. It was more about how can we create a solution that also gets widespread adoption. So that's how Kibo started. We started actually creating this data learning platform where we train AI models from how users and applications interact with the data in the cloud. And then we start our agents, for those of you familiar with reinforcement learning, which is essentially a major step in LLMs, very similar concept. We learn from how those interactions happen, and we start actually pulling different levers in real time and start optimizing it. And we came up with this pricing model which I'll talk about later in the presentation if you guys are interested. But that's how the whole story started. Like we said, you know what, whatever money we save the customer, we take a small percentage of that so that the incentives are aligned. So that's how the whole story started.
That's a super interesting sort of paradigm shift from founders we usually talk to, because it's usually born out of a frustration in a professional space. They're like, this is too slow, this is too expensive. and instead you guys went from a philosophical and like academically based law approach. I was just wondering if you have seen other startups be founded from those sets of principles, or if it's usually more of, I hate this thing, I'm gonna go fix it myself.
It's a little bit of it's a little bit of both, to be honest with you. I think what happens is, it happens both ways. Sometimes, like, to your point, someone's been working in the travel industry for 20 years, like, this thing is way too complicated, I'm going to disrupt this industry, right? So, like, I call them like founders on a mission, where like, hey, I just want to start a company. Here's a space I understand. Let me work on some cool ideas, right? I think in our story was like, we were talking to a lot of customers. Like, I wish I could tell you a fancy story of one morning I woke up, I had this epiphany. But the truth is, actually, a lot of interesting solutions come the other way around. Like, you basically are looking at the really important problem, and you try to figure out, like, what is it what's it going to take to bring this solution to the market? Like, people tell you, oh, I have these 10 problems, and then you can't just go and solve it and then hope that when you come back, they're going to pay for it, right? So you got to figure out what is it that drives them, like, what are the characteristics of that problem, or the solution that will be acceptable to them. So short answer is no, actually, but Databricks has a very similar story, right? So your founders, right, which I personally know, like, they were seeing that MapReduce was really slow. It didn't make any sense. And they came up with this really cool idea of, hey, what if we kept the data that we're running iterative computation on in memory? And there you go. That's how Spark was born and got rapid adoption, and people went from there.
Heard. Okay, cool. That's a very interesting origin story. Now, how much of the internals can you disclose?
Enough.
Let's hear it. All of it.
No, I mean, we have patents in this space. We actually publishing, we have peer-reviewed publications in this space. I can, I won't be able to get into nitty-gritty details of how we, train those models and whatnot, but I can tell you, like, the high-level workflow of, how the whole system works end-to-end, what are the design principles and whatnot. And we have, a dozen of different algorithms running underneath. So even if I wanted, I wouldn't have enough time to get into details of every single one of them.
Yeah, having personally seen the source code for AQE and Spark, it would take several weeks, I think, to discuss all of that.
Exactly.
It's pretty complicated. So do you find that it's a generalizable solution to get, say, 80% of the way there based on the types of operations that different customers or views are doing? Like, do you see, okay, 80% of people who are adhering to, utilizing CTEs when querying data that structure the data and the lazily evaluated instruction set that's submitted, that they can say, okay, we can optimize that really well, and it works pretty darn good. What do you do with the long tail of, like, somebody writing something almost, you look at it and you're like, are you intentionally trying to break this? And what do the optimizers do with that?
I think that's a really good question, actually. All I've done in my entire career pretty much is, like, I've been teaching databases, building databases, and selling databases, right? So, like, I know databases, but, like, when you're saying someone's writing a really bad CTE, like, there are queries, we see it. Like, I'm looking at that query, and, like, I've spent all my career looking, writing SQL queries. I can't optimize this myself, right? So that's our inside joke is, like, we want to be that infinitely competent, infinitely patient DBA, right? But the short answer to your question is yes, actually. And the interesting part is we don't even see the customer's queries. And that was a very intentional decision we made from early on, is that we wanted to, a lot of people think that the hardest part about AI is the technology, which used to be like a decade ago. But now I think we are, as a field, at the place where the technology is not the barrier in many cases. Sometimes it still is, but in many cases it's not. It's the adoption barriers that are basically stopping us, right? People worried about paid implementation, the ROI, privacy/security, maintenance, tuning, hallucination, all of that stuff. So one of those decisions that we made intentionally then was that, because I was involved in another startup before Kibo, and I was seeing how difficult it is to convince. I mean, think about it, like a cloud data warehouse is where you're keeping the most precious digital assets of an enterprise, Now you're a startup, you're going in and say, hey, I have this really cool solution. I'm going to slash your bill by 30%, 40%, 50%, which is a lot of money, as I'm sure you guys are aware of. Like, for cloud data warehousing, it's a very expensive solution. But, they're not going to trust you with the data. So one of the decisions we made was that it has to be a no-brainer from a security perspective. And what it meant was that our models can only learn and train on performance telemetry metadata. So not only do we not store any customer data, we don't even see it, including the query text. We hash the query text. And the beauty of machine learning is that it can actually, we don't have to make assumptions about what is that workload. Like, is this an ETL? Is it a BI? Is it reporting? Is it ad hoc? Is it data science? Is it machine learning? It's just a bunch of numbers. Machine learning looks at this and says, hey, whenever I see this kind of pattern, I see this kind of behavior, I see this kind of cost. And like any other, clever human, the agents learn. They pull a lever, right? And if it basically managed to save the customer money without causing a slowdown, the agent gets rewarded and learns from that. And whenever it does something that doesn't lead to cost saving, it gets penalized and learns from that. So the answer to your question is surprisingly yes, actually. We don't know. We have not seen to this day a single customer for which we've not been able to save some money. But what's that percentage? It depends on a bunch of parameters, how under provisioned they are, how optimized their workload is in the first place, how open they are to letting the models get more aggressive. Some of them ask the agent, we have a slider that tells the agent where it needs to be conservative or aggressive. Whether they save 80% or 20%, it just varies from one customer to another, but it does actually generalize pretty well.
Cool. I have a really saucy question.
Go for it.
Bouncing around. Slightly different topic. So Databricks has been working on this thing called predictive IO, and it seems similar to what you guys do. And all these just cloud things have a bunch of data and a bunch of resources to build something similar. How do you guys differentiate, and how do you guys avoid becoming surpassed by a cloud-specific solution like predictive IO?
No, that's a very good question. So look, like we basically, what we do, like we're super laser focused on just being a data learning platform. We're not trying to replace Snowflake. We don't go to a Snowflake customer and say, you know what, you should go to Databricks. And we don't go to your customers and say you need to migrate to Snowflake if you want X, Y, Z.
Smart.
What we're telling people is whatever, exactly. Otherwise, I would be on this call. We basically tell people whatever data stack that you've already invested in, that's great. Keep that. That with Kibo is orders of magnitude faster and significantly cheaper than that thing that you're already using without Kibo. So one of our other design principles has been like, we should not require any data migration, any infrastructure migration. So whenever the cloud provider or the cloud data warehouse has certain functionality, we actually leverage that. So Snowflake, for example, also has a bunch of really clever internal mechanisms. What we do is that we never reinvent the wheel. Because of predictive IO, Kibo will actually try to leverage that to some extent. And it's not just the optimization. We actually provide FinOps. We have a new technology on the same platform called Smart Query Routing, right? So you could potentially use your own predictive IO to figure out where to route those queries, right? So we use that to decouple the customer's application logic from the application performance. So the user, the customer can just focus on their use case without worrying about cost, without worrying about performance, and just decouple those decisions. So you just send those queries to the Smart Query Router, and it will decide, hey, maybe I need a small, this query needs a large, this one needs a medium, and so on. So short answer to your question is we don't reinvent the wheel. We're not trying to replace the technology underneath. We take advantage of whatever primitive and functionality that's in there, whether it's for better insight, better recommendations, or better actions.
But it seems like a sort of shrinking pie. For instance, Databricks has invested heavily in serverless, and they don't really expose knobs. So there's less that can be tuned. And so what are the sort of sticking points that you anticipate there will be optimizations for the next 5 and 10 years?
Well, that's a very good point. Like, look, when you're thinking about people are trying to So if you sort of just like go back and look at, for example, BigQuery, another player in this space, right? You can just, use spot instances, or you can go completely like, here's a flat rate, or you can say, I'm just going to send you the query, you figure out where you're going to run it and whatnot. There's always a cost performance trade-off, right? You can, when you're going with serverless, someone else is making that decision. You're hiding the knobs and you're automating those knobs, right? So I think the idea of a shrinking pie for knobs is a valid question, but I don't think it's just data learning is not just about knobs, because at the end of the day, I'm sitting next to the customer's most valuable digital asset. I am understanding the data distribution, because that's just the first app that doesn't see the data. We have additional apps that once the customer is in the platform, they actually see the data. They see the query text. They see all of that stuff. If I'm sitting next to your cloud data warehouse, I actually understand your data distribution more intimately than any single individual in your organization. So when something's out of the ordinary when it comes to data quality, I'm actually the one, like me, meaning the agent, right, is the one that actually finds out first that, hey, listen, this column never had null values. Suddenly you have a lot of null values. We're working with a pretty large customer, and turned out that like one of the really important columns had become null for several months and no one really noticed. Right? So we understand those drastic changes in the data distribution. We can actually see certain KPIs. So like, warehouse optimization, which is what you're referring to, is just one use case. But even that use case, I don't think is going to go away, because you are actually creating something serverless. Now people are creating more that just like moves the bar a little bit. Like people are not, worried about what's the server size I'm going to be using, but they're going to stitch it with 5 other data tools and then build a more complex pipeline. And now the question is, how do you optimize that pipeline? One of the major drivers of cost in the cloud these days is dbt models, right? Like, you created like 180, 500 dbt models. Good luck optimizing that. You could be serverless. Like you can remove all the knobs you want. At the end of the day, the question is, the customer has to pay X dollars. What can you do to reduce that cost? Sometimes the solution is changing the knob. Sometimes the solution is changing the query. Sometimes the solution is change the way that you're actually querying your data. So there's a lot more, like, warehouse optimization, workload intelligence, smart query routing, data quality alerts. There's a lot of different ways you can expose that. You can leverage the understanding that you have of the customer's usage behavior and expose it to them at different parts in that data stack.
Heard. Yeah, I couldn't agree more with your perception of that. As somebody who many, many years ago, back when I was doing data science work and like data engineering work, several times at companies I worked with or customers I was working at when I was in the field at Databricks, you always hit that point where you've migrated to a new platform, people start using it, and sort of bad processes have propagated to the new platform. And you open it up, you're like, all right, it's GA, everybody can use it. And you issue your first query, and you're like, man, this is slow. It's faster than it was on our old platform, but it's still slow.
Yeah.
And then you're like, all right, we need to take an entire quarter or 2 quarters and redo the data model properly and get rid of all that old tech debt. And every time that I've been a part of a team that's done that, you open up a whole different problem right after you get all that fixed. So you're like, okay, the query that used to take 4 hours to run now executes in 10 seconds because we actually put the data where it should be and optimize it, put indexes on stuff, everything.
Exactly.
But you still hit that. There's a finite resource limit that's placed in any business, which is the CTO gives you a budget for like, this is how much money you can spend on this stuff. And when you fix all those problems, people just start issuing more queries.
Exactly. They do more
and more.
That's exactly true.
So then you have to like, okay, the queries aren't optimized. How do we and then like what you're tackling is the thing that's every time I've tried to do it or been part of an organization that's tried to do it, it's the hardest thing to fix, which is how do you teach people how to interact with an optimized system properly? And no matter how much effort you put into it, you're never going to be as good as an automated service that can do that.
That's 100% true. And that's actually one of the common questions that sometimes people ask us is like, aren't you afraid that like, the Snowflakes of the world like feel like, you're reducing their revenue. And I'm like, no, actually, we're just their unpaid customer success department because we're just letting, those customers get more work done with less money. So at the end of the day, people, like to your point, when you optimize their workload, they end up actually doing more. It's not that they go back to the CTO. Sometimes they do, but more often than not, the bar just shifts somewhere else. Like now they're going to send more queries. They're going to stitch it with 5 other data sources. And that story seems to be, repeating everyone.
Yeah, that's what we see with Databricks customers all the time. It's like they start off with ETL. They get all their data in their warehouse, and then they then move on to BI, and all the queries suck because of tech debt, and they fix all that, and then it unlocks the ML side. They'll hire a data science team, hopefully somebody who knows what they're doing on that team, and then they'll get some stuff into maybe staging and validate it, and then eventually to production. And you look at the account usage over time, you're like, hang on a second. Like, yeah, they've increased 10x as our customers, but they weren't doing any of this stuff before. And if they're a publicly traded company, you can kind of look at them and be like, geez, over the last 4 years, like they've doubled in revenue. Is that because of us? You kind of want to take credit a little bit for that. Like maybe that was 2% us. And sometimes they'll say that, like, yeah, this unlocked our business insights, and we can now compete against our competitors.
No, that's so true. Actually, one of the I wouldn't say saddest thing, but one of the at least most interesting things that we're seeing is that there's just still a lot of data teams that basically are constantly like spinning their wheels, trying to reinvent the wheel. They're trying to they're too like, because like they have a finite budget, right? And I understand that they're trying to sort of manually patch things up. Like, hey, I'm going to do X, Y, Z. I'm going to reduce the cost. Like, just imagine how much value would be unlocked if you actually shifted those resources into growing your business. To your point, right? Like, all those smart engineers. Like, for example, you're a major gaming company or game development company, software games, and your data team is just spinning their wheels trying to sort of figure out how to leverage Snowflake more efficiently, or how to optimize the Databricks workload. Whereas they're, game development company, they should be focused on like bringing the next and better version of that game and increase their top line instead of being so focused, which is very common these days because of the economy, obviously. Mm-hmm. But you're right. Like, I think when you free up resources from being consumed by all these, cost saving and things that are not the core business of that customer. To your point, you go back and look at it and say, I'm glad that those engineers are actually focused on growing their business rather than how do we pay, a little less to this particular tool that was supposed to free our time up instead of just turning us into, optimizers for this other tool.
So another question, back to sort of your origins from academia. What are some of the skills and concepts that have been essential in founding Kibo? Like, what are the things that you learned in academia that translate really well to being a startup founder, specifically in such a technical space?
That's a good question. I think I don't know how much of this would generalize to every startup, but I can talk about like the kinds of startups that look like Kibo. I sometimes jokingly say that, listen, the reason why Kibo has been successful, like we've been growing our revenue pretty quickly, is not because we have really charming sales reps. The reality is like our product, or, I shouldn't take credit for it, but our product team has built a product that's outsmarting every other solution out there, right? So the reason why we can do it is because it's just, we're not just looking at, hey, I usually give the example of key value stores, right? Like there was an era where every other week there would be a new key value store out there, right? At some point they ran out of names for these companies, right? Because it was very easy to build a new key value store. You would just, and the nice thing about it is like there's 100 plus different key value stores, so you never get stuck on anything. You don't know how to implement XYZ. Guess what? There's 99 other products you can look at. But whenever you're trying to create something for the first time, and it is truly innovative, like not it's just a better user interface, it's just a slightly more optimized version of what everyone else has been doing for the past 20 years, that requires research skills, right? So one of the nice things about academia is that, in the industry, right, like if you want to pitch an idea to your boss or to the company, they think about risk. So oftentimes they try to sort of not put all those apples in one basket. They say, you know what, that's a high reward, high risk, which is usually shorthand for saying we're not going to do it, right? Like you hear this a lot at in the industry, but like in academia, it's the opposite. You get rewarded for taking on hairy, big problems and considering solutions that no one else has developed. Because even when you fail, you learn from it and you go do something. That's because that's what academia is made for, right? Like for people to go and freely innovate and push the boundaries and things of that sort. So I think research skills, which doesn't mean you need to have a PhD, but like the ability to take on an open-ended problem, think outside the box, come up with a solution that maybe no one else has thought about and kind of execute on it. I think that's definitely one area. And the other idea is this whole thing about failing fast, right? We keep talking about failing fast, but that's pretty much what happens in academia, right? Like, so the stealth cycle in the industry, right? If you're thinking about, for example, B2B software, right? Like you have to come up with usually an MVP takes at least 2 quarters, right? After that, you're working with beta customer, that's another quarter. And then we talk about a really fast, like product to market kind of cycle. And then, you have to train the sales team and you start selling some like early customers, getting traction and whatnot. In academia, you're right. You live life writing one paper at a time. So if you have an idea, you submit it to a conference, as soon as like you have some, compelling results, you write up a paper, your code could be complete crap, but you just have a proof of concept. You write up a paper, you run a bunch of experiments to see if it works or not. You don't have to go hire salespeople. You don't have to go, spend millions of dollars on marketing. You just basically go out there and that paper and that idea gets peer reviewed. And if it's a bad idea, you'll find out in like most conferences in computer science, you hear back within 2 months, 3 months latest, right? So you have to fail fast. This idea of being scrappy, and making sure that, you see some results before you invest too much into it. I think those 2 things from our company DNA really did help us out a lot at Kibo.
Must have been something in that lab that you were in, because that exact approach has actually carried over into Databricks R&D.
It is pretty common. This is a space.
But I've heard from other people that have come from FANG companies into Databricks, and their remarks are like, I can't believe we're allowed to like do a spike, and like, yeah, we have to do design docs and stuff, but we get time to do a prototype. And sometimes somebody will give us like, hey, go see if you can figure this out. Like take these, like you 5 people from all these different teams, just take 6 weeks and play jazz, figure out what you can come up with. And sometimes it's a failure, like an abject failure. We'll even release it to private preview, get like 20 customers trying it out. And the response is like, we don't know about this. And then 4 months later, we have version 2.0 that's in public preview, and people are like, this is amazing. Where was this all my life? But yeah, that iterative process of just failing really hard sometimes is critical to like how we release products the way that we do. But a lot of companies in the tech space just don't do it.
They don't do it. No, you're spot on. And I think it's just also a little bit about like getting people with a research mindset. Because like, as someone, I've been writing code from an early age, right? Like I was a programmer before I was a researcher. But like, if I had to confess, like researchers usually don't write the best quality code, right? Sometimes we write crappy code because we're just trying to prove that concept and whatnot. And that drives solid engineers and experience, technically it's sometimes crazy. Like, how can you push something like this, right? But like, I think if you can create an environment where people, like researchers can bring their research skills, solid architects can bring their expertise and like can help like transition once those ideas are de-risked or tried out, help transition to product that scales, right? Like something that's robust and production quality. I think a lot of amazing things happen. Like researchers on their own can either create something that actually, works at scale. But like if you can pair them with engineering teams that, are solid and can take those ideas and transition them. Like obviously that means both camps have to get out of their comfort zone a little more, right? Yep. But I think when you have an environment that's conducive to that kind of collaboration, just amazing things happen. To your point, Ben.
Ben,
Yeah, there have been some comfort zone transitions, but it's exciting. Like everybody gets so enthused about it on both sides because you get the researchers. A lot of people come from that we've hired. They have like 10 plus years post grad. They've been doing research at Berkeley or Stanford or MIT or something, and they come in. They're like, "Whoa, this code's complex." And you have engineers who are like, "Oh, what are you working on? I want to see it." And there's not like I think there's a brief moment of panic on both sides, but then everybody's like, "Hey, let's work together and like let's team up and let's make this awesome." And you just see everybody grow together because you're expanding the mind of engineers to see like what is theoretically possible, and it unlocks a lot more creativity on their side. And then the R&D researchers eventually they're writing like production grade code within a year or so. So you're like, yeah, it's a win-win all around.
No, spot on, exactly. So it's exactly like how you described it, Ben.
Which process do you both like more? Do you like research spikes or more engineering focused work?
I think we do both, but I think it depends what you're trying to do, right? I think
but personally, like which do you enjoy more?
Oh, I definitely enjoy research spikes. I think it's just like, like I said, like you could never pay me enough to go and create another key value store. Right? Like I'm just the kind of person who's like, life is too short. Like if I want to do something, I want to be the first person doing it, right? So research spikes usually have that kind of flavor where like, hey, this is an idea. I might come back and say, guys, that's not promising. That's not going to work. But when you do come back and you come up with a new solution no one else has thought about and it actually works, you get a big spike of dopamine, and it's that makes it all worth it. At least personally for me.
I enjoy 3 distinct points in that development process. The first one is I love seeing all of my dumb ideas fail in the beginning because it shortens the path to getting something that might work.
Mm-hmm.
And it's also kind of fun. I like seeing like, I think I was telling you, Michael, the other day, I was doing something late at night and getting some CI set up in a package that I'm working on. And I wrote some really terrible code because it was like 12:30 in the morning, pushed it to GitHub Actions. And then I crashed the runners, like killed them all, basically effectively like a Stack Overflow. And I just looked at it. I was like, I'm going to bed. But I kind of chuckled to myself. Like, it's been a while since I've broken something like that. And then the next morning I look at what I actually submitted. I'm like, yeah, don't code when you're that tired, dude. And fixed it. And then it passed. I'm like, all right, sweet. But I also love the transition from the proof of concept works and buy-in has been signed off. Like it's been effectively peer reviewed amongst peers at the company. And then banging out that first like production grade version of it. I love that experience. So like, okay, I know how bad my code was. How do I make this actually usable and extensible and maintainable? And how do I just kill all of this complexity that I had to build in the script that I wrote? That's very enjoyable. And then finally the release, not the response. I don't really care about that. I actually look for people like who use it that then tell me why it's broken. Because I love fixing the bugs on the first few iterations. I love that experience. It's like, I know this code because I wrote this crap. I'm like, yeah, I'm going to totally fix that. That's my dopamine hit.
No, I love it. Like, I also like how you're I like the 3 stages, like you're seeing the true value of each of those 3 stages, like, and mm-hmm. liking it for what it is. Like, hey, I would not get from A to C if they didn't have point B in the middle. No, that makes a lot of sense.
Yeah, I think my response is I really like the research aspect, but it's sort of a product of my job because I don't have the opportunity to build really complex, extensible frameworks that have like cool designs. Like I'm writing 1,000 lines of code, maybe 2,000 for like a typical project. And the really fun thing is trying the art of the possible and seeing like, can we make this work? Like, what creative ideas for attacking a problem from a different direction can I employ to make it successful? So, yeah, it's interesting, but they both have their pros and cons. And it's interesting, Barzan, that your angle is research, because I feel like computer science is very fundamentally implementation and optimization focused. Would you agree, or do you think there's a lot of innovation?
That's true. There's a lot of what?
Or do you think there's a lot of sort of innovation and like groundbreaking, like far out there ideas?
It actually depends on what discipline you're looking at, right? So like, I might get into trouble for saying this, but for example, if you just look at databases as a field, like, which is my own field, so I feel like I'm allowed to say things like this. I think the field has kind of plateaued. And you go to AWS, you go to reInvent, you go to like these places where they talk about innovation, and you're looking at this and saying like, that's really cool that like Redshift now has X, but actually Oracle had that like 30 years ago, right? Like, hey, I'm so glad that you guys do auto indexing here, but that happened here. Or like, you have this storage optimized thing here that uses compression. Well, you know what? Actually, Vertica had that like 20 years ago. So the field is plateaued. It doesn't mean there's no innovation, but like, if you're just trying to build another database, a lot of it has been tried. And I'm not saying there will never be enough innovation. I'm just saying the number of new ideas that are like radically new and actually are effective, we're running out of those ideas. Like, the field has matured, which is a good thing, right? It means we can go and build the next set of, AI enabling applications on top of what we've learned. Like, now we wrote a paper a few years ago with one of my former PhD students about database learning. So the idea was like, okay, now let's say you do have a database that's optimized, but every time, if I keep asking you, the example I give is about cars, right? Let's say that you're like me and you don't know anything about cars, right? Then if I ask you a question about this particular model of Ferrari, like, you're going to go online and look it up and give me the answer. If I keep asking you questions about cars, you're going to keep Googling it. But after 2-3 days, you're going to pick up a few things. You're going to learn. It's going to take you less and less time to come up with an answer to car-related cars, right? Because we're humans, like, we learn. But databases don't learn, aside from like very basic things like, hey, I cached this data, or I cached that result before the data changed. Every time you go, submit a query, the database does a bunch of work, send you the results back. For the most part, that work is lost afterwards. You go back and it starts like the databases don't learn. So that the vision that we basically presented, and we actually built a proof of concept on it, was like, how can you build a database that actually learns over time and becomes smarter every time that you query it? Because think about it, like, if I ask you, hey, what's the average sales for this particular region per department, and then tomorrow ask another question that kind of overlap, like maybe said, hey, what's the total number of transactions per region for the entire country? The fact that I know something about that region should help me come up with an answer to the second question a little faster, right? So I think there is still innovation, but it's very field specific. Certain subdisciplines within computer science are well researched. People either have moved on or they need to move on. There are people who still haven't moved on, and they still keep iterating over similar ideas. Hey, actually, I found this corner case where I can make the indexing like 5% more efficient. But there's a lot of interesting things, especially like the time we're living in with LLMs, with machine learning, with hardware acceleration, that we can still actually come up with pretty cool ideas. Like, human mind doesn't run out of cool ideas. That's a nice thing. It's just like, maybe you fix something, you go and create a new discipline.
Curious for both of your guys' opinion, what are the frontiers that you're excited about, or the new piece of technology that in the database and data querying space that you think are going to be game changing?
Then why don't you start?
I think for data querying, the ability to map to an entire data warehouse or entire system of RDBMS like implementations that exist in an organization, and for you to be able to talk to an agent and ask a very complex question, and you get the accurate response from all of that without you having to build all of the interfaces to that. Because today you can theoretically do that, right? You can create a bunch of tools that all issue all of these different queries to all of these different platforms, or you can, like basically fine tune a model on the metadata of your tables and your databases. And I don't think that anybody's going to pick that up to get to, a high 90% accuracy response rate. Like we offer something called Genie, right, at Databricks, and that's language model interface to query Unity catalog tables. And in demos, it's incredible, like amazing. I played around with it. I'm doing integrations with it. I'm like, man, this is so cool. The fact that I can, put a 100-column table with 1 million rows, and I can ask it just plain language questions, and it figures it out. And I can do this with 5 different tables, and it'll generate those queries for me. And it's pretty performant because of that optimized engine in the background. But then I'd point it to our internal tables or data that I had written 2 years ago into Unity catalog during the demo days of that. And I issue the same query, and it loses its mind. And then I'm like looking at it like, why does it work so well on these tables that I created, last month? And that my old data, it's just not good. And then I just go into the UI and I'm like, oh yeah, there's no metadata here. Like there's no comments anywhere explaining what this table is, what's in it, or the conditions for the ETL that is actually putting the data in. And then the column names are almost intentionally obfuscated because I was just doing shorthand nonsense. And I have no parameter comments anywhere of like what this column contains. So it's making guesses. It's inferring from what metadata it actually has. And I'm just like, okay, there's got to be a better way to do this. So I think that the golden goose out there is for Barzan and his team to figure out, how do I do that with the table? How do I generate the metadata that is highly accurate, that is contextually relevant to this business in a way that, interfacing with an agent will work properly?
Yeah, but just real quick before you jump in, I have so much beef with Genie right now. The account teams at Databricks have sold the proof of concept to like 5 different customers, and then the customers are like, "Oh, great! So now you're going to build me this agent." I'm on 3 of those projects right now, and we just have to like lower the expectations 3 orders of magnitude because it's just not there yet. It's a really cool technology, and it will be there soon, but the demo is not what it is in reality.
Right.
But yeah, over to Barzan.
No, I think data explanation is one of those areas I'm also really excited about. But like, if I'm kind of zooming out, like it's very easy. Like if you ask me what's like, if I had a magic wand and I could solve any problem, I would obviously say world hunger and like cancer, right? Like, but I'm also very realistic about my own skill set, right? So I think the most important thing, like the way I'm looking at it, as someone who's excited about innovation, but also like I want to make sure it's practical and gets adoption, right? And part of adoption, like to me, has four legs, and one of it is that it has to work, right? Not just beyond the demo, to Ben's point, right? Like it has to work. Otherwise, you get a bunch of people who are really excited and get really frustrated, which I think is a big one of the barriers to some extent with AI is like people, if the level of excitement doesn't match that expectation, then they get burned out. And I don't know when's the next time that the CIO was going to sign off on something that had the word LLM in it, right? So if I'm looking at it from that perspective, I think the key to success would be to focus on what the intersection of what can be automated and what should be automated. Sometimes people try to automate things that shouldn't be automated, or the things that should be automated but cannot be automated with today's technology, because they're inaccurate, they're inefficient, unreliable, all those reasons, right? So if I'm looking at that intersection of what can and should be automated, one thing that's actually working on that I think is very exciting is like with LLMs, we've seen massive success with actually query rewriting. Like as someone who's been like just dealing with queries for the past 20 years, it can actually rewrite queries that we never thought possible. But it's not just like, hey, ChatGPT, can you please rewrite this query for me into a more efficient form? Because actually 4 out of 5 times, or I should say 8 out of 10 times, it actually gets a query that either doesn't even compile, or it actually compiles but gives an incorrect answer, or it compiles, gives the correct answer, but it's actually slower than the one I started with. So like we've created this framework around it. Like the paper is out there for those who are interested in the audience. It's called Gen Rewrite. We actually, we've created this really cool cycle where we basically get, we interacting with the LLM to actually come up with what we call human readable rewrite rules. So like when we rewrite it, we actually turn it, once we validate, turn it into a rule. And then when a query comes and we use those rules as actually as hints to the LLM. So now we basically pretty accurate, like 90+% accurate with, in the sense that we can actually, whenever we rewrite the query, we have pretty high confidence that it's actually correct. And it's actually more efficient than the original query. And the nice thing is that this database of human, I forgot what we call it in the paper. I think it's human understandable or human rewrite rules, something like this, HR2L, something like that. That database actually keeps growing. So it's like more along this vision of creating a database that keeps getting smarter over time. Like ChatGPT, the more people are interacting with it, it's also getting smarter and smarter. So like creating a system that gets smarter over time, the more we use it, I think is also super exciting. But I think we will get to a place like then that we will be able to explain a lot of interesting things. Like, hey, why did my sales in the grocery department at this particular Walmart store, go down last month compared to the, other stores, comparable stores, right? And we will never be able to fully automate experimentation and causality, but at least we will be able to show the most likely causes to the domain expert, who will then have that domain expertise, which should not be automated or cannot be automated, at least today, to tell us, hey, you know what? These are the top 3 reasons. I think it's because we had too many people, out of office, or there was this local event at this other place that was not here. So I think that's the line that I'm really excited about, just working on things that can and should be automated.
Yeah, that example brought to mind an old example that I used to use when teaching new data scientists to teams at past companies about the difference between correlation and causality in intelligent systems. And I'm like, here's this model. And I had this data set that I would always use that was, it was basically like year-round temperature at a park in New York City. And then another column was like amount of ice cream sold. And you build a very simple model, a regression model, and then use explainability tools and causality tools on that data. And of course, it's like, hey, I want to optimize sales. And what does it come up with? It's like the thing that you need to change is just increase the temperature. And that's going to definitely like trying to teach people like, hey, be careful of how you interpret things that come out of, an algorithm.
Exactly.
And I think that the thing with like the explosion of Gen AI and its popularity and its democratization, the only thing that I see as potentially disillusioning in that, as these capabilities become greater and greater over time, like, hey, I can query all my data and I can ask whatever question I want, and I can bolt onto this tool that's going to do this causality analysis for me. And somebody's like, inevitably a system's going to be built that has those features that can do these sorts of things, and it can query the right data. And then somebody's going to say, how do I make my sales go up? And they're going to ask that to the system, and the system's going to go and it's not going to say increase the temperature of the planet Earth in January, but it could do something similar to that in their business. And they might not know, like, oh, maybe if I focus my efforts here, turns out you're cannibalizing from another part of your business and, creating chaos or whatever. I think with incredibly intelligent and reliable systems, it could create like trust issues with people with those systems. Is that something that in academia people are thinking about?
I think so. Not as much, and not as many but there are some actually. Like we published a paper called DB Sherlock a few years ago. It wasn't using LLMs, but the idea was like how we can actually incorporate causal models into a system that can show the most likely causes, and then use the causal model to actually help users, so that we don't tell people what caused the rain was that, your wife took the umbrella, but we say, hey, these are most correlated with each other, and then we can use causality models so that the system learns over time. But I think there's some people who are looking into it, but not as many, to be honest with you, not as many as I wish these days.
So I've got a silly question for you. You've been in the space for a while and been doing research for a very long time, and we're likely exposed to the things that everybody thinks is pure magic nowadays, about like, oh my God, this ChatGPT is the best thing ever. It's so smart. Anybody who's been in AI, like dealing with advanced computer science for decades, is going to look at that and be like, yeah, we had these like a while ago. They've been around a while. Maybe not Transformers models. They're slightly more advanced, but they're growing off of the shoulders of giants that came before. Were you doing like a table slap or knee slap with a bunch of other professors saying, I called it, I knew it was going to happen this year, where my grandma knows the name of something that is involved with artificial intelligence?
That's a very good question. I think when you spend a lot of time in a space, you actually see like certain things that become trivial, or become certain to you, become clear to you, right? But like to outsiders, because that's all you know, right? Like if all you've done all your career is like this very narrow area, which is, sadly the situation with a lot of us in academia is like we know everything about a very little narrow topic, right? So it becomes pretty clear, but to outside it looks like magic. So yeah, I would say like, I had students who worked on like transformer models and whatnot. So like we were seeing the advances that are coming, but I think what surprised all of us is how quickly the public kind of was impressed with it, right? Like we go to a conference, we say, hey, we improved this accuracy by like, 0.5%, and we clap for each other and we get excited, right? But like eventually when it becomes good enough, then everyone else is, also gets excited about it, because they're not there in the journey where like, right, it was just growing little by little, where it's harder to see it. Like they saw like, hey, there was like sci-fi movies and now this is actually here. So
right. Yeah, we even got to see that over the last, 8 years or so at Databricks with even traditional ML, where you look and like the first couple of months, or like probably the first year that MLflow is out, and you're looking at the statistics of like how many people are saving what types of models. You're like, oh yeah, we've got like 100 users that saved sklearn models and deployed them, and a bunch of people doing XGBoost. Like this is exciting. And then you look now and you're like, how many millions of these were saved in the last week alone? And it's become so commonplace. Like every business has these things, and not just one, but you look, an account might be hitting that API for logging that thing 500,000 times a week. It's just like, wow, that's crazy. It's so commonplace. But 10 years ago, that would have been like, whoa, this is state of the art. And then people that have been doing that stuff for a long time, like when I came in and would talk to like new accounts that we got on, they're like, we want to learn more about this new thing called data science, and we want to like understand it. Like, new thing, like, this has been around for a long time, like, but way before I was born. They're like, what? No, we just heard about this thing that you can do. I'm like, yeah, the paper for that was written like before World War One, before computing. So that speed, like what you talked about, it surprised me a little bit. I didn't think it would hit zeitgeist level of like, hey, everybody knows this thing and everybody's got an account on this thing. It's exciting, but it's also very surprising.
No, spot on. Yeah, exactly.
Cool. So I know we're coming up on time. I'll quickly summarize. Really interesting conversation. Some things that stood out to me are research skills are very valuable for innovation. And in academia, you can typically learn the fundamentals of research, at least one would hope. And then also fast failure is essential. Sort of at a macro level, a lot of organizations are turning off knobs. So there's less configuration and customization you can do. But despite that, there will always be additional layers of infrastructure to optimize. People will start using those as discrete blocks in more complex systems. And then some future areas of innovation that we're excited about are agentic querying and then query rewriting. And if you guys are curious about the paper, it's called Query Rewriting via Large Language Models. So Barzan, if people want to learn more about you or your work, where should they go?
If you Google my name or go to Kibo.ai, that's our company. You can get live demos of what we do. If you're using Snowflake or near cloud data warehouse in any capacity, and you're interested in auto optimizing it, diverting some of that manual effort or infrastructure bill to some other areas of your business. It's out at Kibo.ai, or Google my name and look at my academic homepage with a bunch of papers, or reach out to me via LinkedIn.
Cool. Thanks so much. All right. Well, until next time, it's been Michael Burke and my co-host,
Ben Wilson.
And have a good day, everybody.
Thank you so much.
Next time.
Bye.